Yesterday we have seen some sums on root locus. Today we are going to see more sums on root locus. Then we are going to see design of control system using root locus. Based on that one sum. So it is not usual root locus. If you see this pattern of G of S, you should remember that it will have a circle of radius square root of A square minus AB. It will have a circle of radius A square minus AB, and its center will be minus A comma 0, minus A comma 0. So it will have a circle because this is the form modulus of A is greater than modulus of B. Therefore, it has circle. It has circle. Its radius is, its center is at minus 6 comma 0, and the radius r equal to square root of a square, that is 36 minus ab 24, that is equal to how much? 12, root 12. So r equal to radius equal to root 12. So what is the question? Sketch the root locus plot with k as variable parameter. K as variable parameter, because root locus means we are varying k. We know, but anyhow it is mentioned. Show that loci of complex roots are part of circle. Definitely it forms a circle. So determine the breakaway break-in points, if any. Determine the range of k for which the system is underdamped. Determine the value of k for critical damping. Determine the minimum value of damping ratio. Minimum value of damping ratio. Minimum value of damping ratio. So how to find breakaway and break-in points? So what are the poles? The poles are 0 comma minus 4. Zeros are at minus 6. So what is the root locus? The root locus branches at one is at 0, and another one is at minus 4, and 0 is at minus 6. 0 is at minus 6. Zero is at minus 6. So this is both are part of root locus. Both are part of root locus. So definitely there will be a breakaway point. So this is also part of root locus up to infinity. But this is the end point. This is also an end point. Therefore, there will be a break-in point. So we have to find. You can quickly find. One way of quickly finding is, what is the radius? 3.5. So center is at minus 6. Center is at minus 6. Radius of the circle is 3.5. Subtract 6 minus 3.5. How much? Add minus 3.5. 9.5 you will get. So the breakaway and break-in points will be this much 3. So we can have this much. So minus 9.5 is break-in point. Minus 6, add 3.5. You will get how much? Minus 6, 2.5. So breakaway point is at minus 2.5. Minus 2.5. How I got? Are you able to understand? Because it is radius. So now we can draw the root locus. Draw a circle of center. Center is minus 6 comma 0. Radius how much? This radius is 3.5. But it's asked. We can, if they directly asked to draw the root locus means that's all. But they are asking determine the breakaway and break-in points. That's why we have to find dk by ds. We have to find dk by ds. Now let us find the breakaway and break-in points. K equal to s multiplied by s plus 4 divided by s plus 6 minus dk by ds equal to, we have to invert it, that's all. You have to write the inverse. K equal to inverse. K equal to 1 by g of s minus 1 by g of s. How we got this? 1 plus g of s equal to 0 is characteristic polynomial. Here k g of s. Therefore, k g of s equal to minus 1. Therefore, k equal to minus 1 by g of s. So, based on that, I wrote directly, I got this k equal to minus 1 by g of s. So, if you differentiate, what you will get? S plus 6 whole square, s plus 6. If you differentiate s square plus 4s, what you will 2s plus 4 minus, if you differentiate this, write as such s square plus 4s. If you differentiate this, you will get 1 equal to 0. Therefore, what you will get, this implies 2s square plus 4s plus 12s plus 24 minus s square minus 4s equal to 0, or s square plus 12s plus 24 equal to 0. Find the roots. S equal to minus 9.5, minus 9.5 and minus 2.5. S equal to minus 9. That's what we found. In the graph also we found, because we know the radius. Radius equal to what? Square root of a square minus ab. So root 12 equal to 3.5. We got the same minus 9.5 and minus 2.5 are the breakaway points. We got this part is over. Sketch the root locus we have drawn. Determine the breakaway and break-in points, if any. Determine the range of k for which the system is underdamped. System is underdamped. When it will be underdamped? When the roots are complex conjugate. When the poles are complex conjugate underdamped. Because zeta line, you see, zeta line, this is zeta 1. This line is zeta equal to 1. This line is zeta equal to 0. If it is on the j omega axis, zeta equal to 0, always it oscillates. Sinusoidal. If it is on the negative real axis, no oscillation. Zeta equal to 1. If it is between these two, 0.3, this is 0.3, this is 0.7, 0.8. If you approach the real axis, it becomes 1. So if it is complex poles, then only there will be oscillation. So determine the range of k for which the system is underdamped. If zeta is not equal to 0, zeta is not equal to 1 means zeta is between 0 and 1. Underdamped means zeta must be 0 and 1. So the angle must be 0 and 90. This angle theta must be, or in other words, theta must be 0 and 90. Not equal to 90, not equal to 0. But between 0 and 90, theta, cos theta. Cos theta is zeta. Therefore, that we have to find. It means if it is on the circle, it is underdamped. Not exactly at this point, the breakaway point, except the breakaway point, all other points on the circle are underdamped. Am I correct or not? All points on the circle, except on the real axis, are underdamped points. except on the circle are underdamped points, except this point A and B, except A and B, all other points on the circle are underdamped. At A and B, it is at A and B, it is equal to zeta equal to 1. At A, zeta equal to 1. At B, zeta equal to 1. All other points are zeta less than 1. Find the range of K. So find K value at A. Find K value at B. If it is less than that value of K, that is underdamped. At A, critically damped, zeta equal to 1. At A, critically damped. That is D, question number D. C and D are same. Find the value of K at A. At A, K at A, suffix A, K equal to, from A, draw line to all poles, minus 2.5 to 0. What is the length? 2.5. Then, what is the length from minus 2.5 to minus 4? What is the length? 1.5. Am I correct? 1.5. What is the length from 2.5 to, 6? 2.5 to 6. What is the length? 3.5. That is 0. That's why it must be in the denominator. 3.5. What is the value of Ka? Find Ka. 2.5 multiplied by 1.5. Ka equal to 1.0. 1.07. Therefore, when K equal to 1.07, the system is critically damped. The system is critically damped. If it is, what is KB? KB equal to what? B equal to what? 9.5. So, the length from B to first pole P1 is 9.5. 9.5. 9.5 to another pole, that is 4. 9 minus 4, how much? 5.5. 5.5 divided by 9.5 minus 6, 3.5. 3.5. That is equal to how much? 14.9. When K equal to 14.9, it is critically damped. If it is less than 14.9, it is underdamped. Less than 14.9, it is coming like this. When it is K equal to 1.07, it comes here. If you slightly increase, it come out here and come out here. If you increase, when it becomes again 14.9, it becomes critically damped. Therefore, when K is between 1.07 and 14.9, it is underdamped. 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 When it is critically damped, when K equal to 1.07 and when K equal to 14.9 is critically damped, no oscillation. Determine the, when it is over damped, less than 1.07 and greater than 14.9. Greater than 14.9. Between 1.09 and 14.9, it is underdamped. Up to 1.07 and 14.9, it is critically damped. Between 1.07 and 14.9, it is underdamped. Up to 1.07 and 14.9, it is critically damped. Above 14.9, it is over damped. It is over damped. Less than 1.07, it is over damped. Sluggish. The system is sluggish. So less than 1.07 over damped. It is not asked, but sometimes if it is asked, you have to write. It is less than 1.07 over damped. Greater than 14.9 over damped. The next question is, determine the minimum value of damping ratio. Minimum value of damping ratio. What is the plot? This is the plot. A circle. So when it will be maximum, what is the value of maximum value of zeta? 1. Minimum value of zeta? 0. So if the angle increases, it decreases from this theta increases, it decreases from 1. If it comes here, further decreased. That is, if this point and this point, suppose this point is A and this point is C, means if you compare A and C, D and E are lesser zeta. If you go above, if you come here, further zeta is decreased. F and G further decreased. H, this is the point at H. If you draw any line, after that it is not touching the root locus. So this is the minimum zeta is at H only. Minimum zeta is at H only. If you draw a tangent to that circle, where it touches the circle, that point is the minimum zeta. Minimum zeta. What is that zeta value? Measure this angle. Measure this angle. What is that angle? Theta equal to what? Theta, that point is 4, 2.75. That point is, the tangent is at 4, minus 4, J 2.75. That point is minus 4, J 2.5. That coordinate is minus 4, J 2.75. What is that angle? Theta equal to tan inverse of imaginary part, that is 2.75 divided by 4. What is that? Tan inverse of 2.75 divided by 4 equal to how much? Theta equal to 34.5. What is zeta? Zeta equal to cos 34.5. That is equal to how much? 0.82 is the minimum zeta. If you come down, D and B, F and G, all those points, it is greater than 0.8. You understand this point? So, what is the value of K at H? For the zeta value, what is the value of K? K equal to, that point is H. HP1, that HP1, modulus of HP1 multiplied by modulus of HP2 divided by modulus of HZ1, only 1, 0. What is the distance? We can use that polar coordinate method, need not measure. That modulus of HP1 equal to, what is H? Minus 4 plus J 2.75 minus of, what is that pole? 0. Therefore, find the angle, find the magnitude, minus 4 magnitude. Polar coordinate minus 4, 2.75. 4.85. 4.85 HP1. Similarly, find HP2. HP2 equal to modulus of HP2 equal to minus 4 plus J 2.75 minus, what is the other point? Minus 4. Am I correct? Or? Minus 4. That is obvious. 4 getting cancelled, therefore 2.75. 2.75. No need to call that function part. Only imaginary part is there. Modulus of 2.75 is 2.75. What is modulus of HZ1? Equal to modulus of minus 4 plus J 2.75. J 2.75. And that 0 is minus 6. Minus of minus 6. Minus of minus 6. That is equal to 2 plus J 2.75. What is that modulus of that value? 3.4. 3.4. Therefore, K equal to, K at H equal to 4.85 multiplied by 2.75 divided by 3.4 equal to how much? 3.92. When K equal to 3.92, it will have a minimum damping value. Minimum. That is 0.8. That's all. We'll see in next class.